Hello everyone. In this video we are going to look at the equations of motion that we will be using in the case of the 1D motion. Now already in the previous video we have derived the equations of motion which will be for the motion where the acceleration will be uniform or acceleration is going to be what? Constant. So equations of motion can be used only when the acceleration is constant. So here we will see how these equations of motion will get changed when we talk about the one-dimensional motion. See, first when we say one-dimensional motion, right? So let us say the initial velocity of the object is along a particular direction. It need not be a horizontal straight line, it will be a straight line. So let us consider this to be the horizontal straight line. Okay. Now the other parameters of motion, because the motion is confined to this straight line, whether we talk about the displacement or the final velocity or even acceleration. So we discussed about it when we have taken the idea of uniform acceleration in 1D motion. We have said that the velocity and accelerations, all of them must be in the same straight line. Now the thing is all these vectors may not be in the same direction, because straight line means what? See, we said initial velocity is, for example, towards the right side. There is also one more direction possible. Along the straight line there will be two directions possible. So here if you take one as the right side, other will be what? Left side. So it is possible that these quantities, the vector quantities, right? What are the vector quantities here? U, V, A, S. All these are vectors. There is one quantity which is a scalar, which is the time. Okay, so all these are, we are calling as what? The parameters of motion. Okay. Now even of course in the derivations that we have done for the equations of motion, we have seen the formula for the S subscript n. Sn is called as what? Displacement in the nth second. Displacement in the nth second of the journey. Okay, so those who are watching this video, probably you need to look at the video where we have done the derivations for the equations of motion, because this is like a continuation to that. Okay, now when we look at these equations of motion, so I'll just write down the equations of motion. V is equal to u plus at, S is equal to ut plus half at square, v dot v is equal to u dot u plus 2a dot s, and then the Sn formula, what is it? U plus, either we will write as a into n minus half, otherwise u plus a by 2 into 2n minus 1 when we take the LCM inside. Okay, so these are the, you can either use this version or this version. Okay, now these are the equations of motion which are in the vector form. So here the thing is, if assume all these vectors are in the same direction, what is the assumption we are going with? If we assume that all these vectors are in the same direction, means what? U, V, S, A, all the vectors are in the same direction. Let us say the direction is the right side over here, all of them. So no quantity is towards the left side, all of them are in the one direction. But what we need to keep in mind, there are two possible directions. Either they can be, in this particular case only, either they can be towards the right side or they can be towards the left side. If all of them are in one direction, let us mark that direction as the x-axis. So what will be the unit vector in the direction? I cap. So the final velocity can be written as what? If the final velocity magnitude is v, we can write it as what? V into I cap, because it is in the positive x-axis direction. The initial velocity can be written as what? U into I cap. U is what? The magnitude. Acceleration can be written as what? A into I cap. Displacement can be written as what? S into I cap. So everything. So whatever is the vector, right? Any vector can be written as what? The magnitude multiplied by unit vector along the direction. What is the unit vector in the direction? I cap. Now we will pick up one of these equations. We will see how the equation will get modified. Let us pick this one. V can be written as what? V into I cap. So I'll erase all these other ones, because we'll do it one by one. So let us look at the first equation itself. Now what is it that we are saying? We are saying that the first equation will be modified as what? V bar can be written as what? V into I cap is equal to, right side what is there? U into I cap plus A into I cap into T. So now look at V into I cap is equal to what? We'll just take the I cap common out. U plus AT into I cap. So what is the component of I cap on the LHS? V. That should be equal to the component of the I cap in the RHS. When we equate means what? The component here must be equal to component there, right? Which means what? V should be equal to what? U plus AT. Here what is V? The magnitude of the final velocity. U is what? Magnitude of the initial velocity. A is what? The acceleration magnitude, just the values. T is what? The time. So what we see is a vector form of the equation is getting converted into a simple scalar type, because here what are these values? V is the final velocity magnitude, U is the initial velocity magnitude, A is the acceleration magnitude. So the equation is becoming like what? Scalar equation. This is for the 1D motion. But one thing we need to keep in mind, the assumption we have made is what? All these are in the same direction. That is the assumption we have made. Correct? Now we'll just take a look at the other equations also. What is the second equation? S is equal to ut plus half at square. Correct? So in this just so S will be what? S bar will be S into I cap. U will be what? U into I cap. A bar will be what? A into I cap. So we'll just have to substitute them. So look at it. This is what? S into I cap is equal to what? U into I cap into T plus half into A into I cap into the T square. Same thing. I cap is equal to what? Here we'll take I cap common out. Half AT square into the I cap. Now when we equate them means the component of I cap on LHS is what? Yes. Should be equal to UT plus half AT square. Means the displacement magnitude S is equal to what? UT plus half AT square. We'll see that this is also becoming like what? A scalar equation. This is also becoming like a scalar equation. Okay. Now what is the other one? V dot V is equal to U dot U plus 2A dot S. What is this? V will be written as what? V into I dot another V into I. This is what? U into I dot U into I. This is what? A into I dot S into I. So here V is the scalar magnitude, right? So we'll take V square into I dot I. This is what? U is the magnitude or the scalar into I dot I plus 2. A is also a number, S is also a number into I dot I. What is I dot I? Dot product of I vector with itself is what? 1. J dot J also will be 1. K dot K also will be 1. So what is it? This is 1, which means we'll have LHS V square is equal to what? RHS U square plus 2AS. This is the third equation. Here also we are having these V, U, A, S and representing what? They are representing the magnitudes. V represents the final velocity value, U represents the initial velocity value, A represents what? Acceleration value, S represents the total displacement value. Okay, so like that we are able to convert the equations of motion into the scalar form. Okay, now we have one more equation, which is the displacement in the nth second of the journey. What is the displacement in the nth second of the journey? Okay, so what is it? What is the formula we have derived for this? Sn is equal to what? U plus A by 2 into 2n minus 1. We have said there are two forms in which we can have. Also we can write as what? Instead of A by 2 into 2n minus 1, we can write it as what? A plus n minus 1, n minus half, like that. Okay, so look at it here. Sn will be what? I cap is equal to U into I cap plus A into I cap by 2, 2n minus 1. So what is it? Sn into I cap is equal to, here we'll take I cap common, U plus A by 2 into 2n minus 1. Here also I cap component on both sides must be same, because we are equating both of them. Okay, so which means what? Sn will be equal to what? U plus A by 2 into 2n minus 1. Otherwise we can also write it as what? U plus A into n minus half. So you'll see here this equation is also becoming like what? A scalar equation. This is also becoming like a scalar equation. Now there is one more result we have got. So in case of uniform acceleration, right, the average velocity formula. Remember what is the average velocity formula? V bar plus U bar by 2, or basically the initial velocity plus final velocity vectors by 2. So if you look at that equation, right, the average velocity will be equal to what? The initial velocity plus final velocity vectors by 2. So here average velocity will be what? Its magnitude into I cap. Everything is in the same direction. U into I cap, V into I cap by 2. So it is what? U plus V by 2 into the I cap. This is our. So again we'll have to equate the I cap components, which is what? The average velocity value is equal to what? Initial velocity plus final velocity by 2. So here we are able to convert all these equations and results into the scalar form. Okay, so just to look at what these relations are. So here we're talking about U representing what? The initial velocity of the particle at t is equal to 0. V representing what? Final velocity after time t. A is what? The acceleration. So here the acceleration will be what? Constant. That is the context here, uniform acceleration. And S is what? The displacement in the time t, total displacement. S is what? The total displacement. Okay, so what are the results we are having? We have the scalar versions that we'll use in the 1D motion. V is equal to U plus AT, then S is equal to UT plus half AT square, then we have V square is equal to U square plus 2AS, and we also have the displacement in the nth second. What is this? This is the displacement in nth second. This is also an important result. So all these are in the scalar form. But the thing is, we have got these results by assuming that all these vectors are in the same direction. By assuming that all these vectors are in the same direction. But is it possible that all these vectors will be in the same direction? It is not, right? Because some of the vectors can be, because there are in straight line also. What are we saying? If you, for example, take the horizontal straight line. If you take the horizontal straight line, there are two possible directions. Here in this case, this is one possible direction, this is the other possible direction. Then what is going to happen if these quantities are having different directions? Then we are going to just bring in the concept of sign convention. So we are going to use the equations as it is. What are the equations? V is equal to U plus AT, S is equal to UT plus half AT square, then V square is equal to U square plus 2AS, then S subscript n is equal to what? U plus A by 2 into 2n minus 1. So all these results we are going to use as it is by bringing in the concept of sign convention. So first we will try to understand what is this sign convention concept. Okay, so let us say that in the derivation, right, we have taken that all of them are in the right side direction, that is, we are calling as the I cap. So let us say this is the direction of the initial velocity. That I cap or positive x-axis is what? The direction of the initial velocity. And if the acceleration is in opposite direction, the acceleration is what? In opposite direction. Okay, and final velocity is in the same direction as the initial velocity. So understand clearly what are we saying? Initial velocity and final velocity are in the same direction. Acceleration only is in opposite direction. Now look at the original equation, what we have, vector form. V bar is equal to what? U bar plus A bar into t. V bar is equal to what? U bar plus A bar into t. So here V bar will be written as what? V into I cap, because it is in the I cap direction. U bar will be written as what? U into I cap. But what about A bar? A bar exactly opposite direction. Means we have to take it as what? Minus I cap, right? So A bar has to be written as what? A into minus I cap. A bar has to be written as what? A into minus I cap. Now look at it. V into I is equal to what? U minus AT into I. Which means if you equate the components, what we are going to get? V is equal to what? U minus AT. So what we are essentially doing is, the acceleration is in opposite direction, means in this equation, right, what is the equation we have got? V is equal to U plus AT. Let us say, for example, the acceleration is 2 meter per second square, opposite direction. Then here in this equation, instead of 2, what we have to keep? We have to keep minus 2. So that is how the equation will get modified based on the sign convention. So what is the sign convention concept here? It is very simple. If you consider the quantities in one direction as positive in these equations, like in this case, what are we taking? The direction where the initial velocity is present, we are taking it as what? The positive. The quantities that are in the opposite direction, right, they will be substituted with values negative. Like in this case, the acceleration has to be substituted as what? -2. Then the equation is going to be matching. So this sort of an adjustment, right, is what we call as the sign convention. So we are going to use the equations as it is. We are going to use the equations as it is. V is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as, and Sn is equal to what? U plus a by 2 into 2n minus 1. We'll use the equations as it is. But the only thing is, like the way we have seen, right, if a vector is in opposite direction, means instead of I cap, we'll get minus I cap. So we have to substitute that particular value with its negative value. So we'll talk about the basic concept of what is sign convention. We'll talk about the basic concept of sign convention. What is the basic concept of sign convention? If quantities in one direction, so we are not mentioning what is it. If quantities in one direction are taken as positive, right, then the opposite there, because here there will be only two possibilities, either one direction or the opposite, then the opposite direction quantities will be substituted as what? They will be substituted as negative. So this is the basic concept of the sign convention. Now here, when it comes to the straight line motion, right, particularly we'll talk about these two examples. One is the horizontal straight line motion, and second will be the vertical straight line motion. So here we'll talk about what is the sign convention we will follow in the case of the horizontal straight line motion. So what we are discussing is the basic idea of sign convention. If you take one direction to be the positive, the quantities in the other direction we have to take them as what? Negative. When it comes to the horizontal straight line motion, right, what we will generally follow as sign convention is, because our journey will begin with what? Initial velocity, right, we will take the direction of the initial velocity, whatever it is, maybe to the right side or maybe to the left side, we will take that as positive. So what is the sign convention in case of horizontal straight line motion? The u bar direction, so whatever is the initial velocity direction, will be taken as what? Positive. Means whatever the quantities in that particular direction, all of them will be taken as what? Positive. And the direction opposite to u bar will be taken as what? Negative. Because the basic idea of sign convention is what? In these equations, when we are substituting the values, quantities in one direction we have to take the values as what? Positive. Opposite direction quantities we have to take it as negative. But we have to fix one side as positive, one side negative, right? Which means we are going to follow the sign convention. So generally for the horizontal straight line motion, what is sign convention we follow? We'll say all the quantities in the direction of the initial velocity will be what? Positive. And the quantities which are in the opposite direction, we'll take them as what? Negative. This is the sign convention we will follow in the case of the horizontal straight line motion. Okay. So we are going to use these equations of motion as it is by following the sign convention. Now we'll see some problems. A body having uniform acceleration of 10 meter per second square has a velocity of 100 meters per second. So when they give a statement like this, right, it represents that both the acceleration and the velocity are in the same direction. In how much time the velocity will be doubled? So this is also another hint that when they say the velocity is doubling, means what? The acceleration is actually in the same direction as the initial velocity. So look at it. So here initial velocity, we will take it as what? 100 meter per second. What about that is our u? What about the acceleration? Since the acceleration has to be in the same direction, so whatever the direction the initial velocity, acceleration has to be in the same direction, then only the velocity will get doubled. Okay, so acceleration is given as what? 10 meter per second square. So we are taking it as positive, and we need to find what is the time. where the velocity will get doubled. Doubled means what? The final velocity will be double. Initial velocity is 100. Final velocity has to be how much? 200. We have to find the time. Think about it. U, A, V and T. What is the equation we have? V is equal to what? U plus AT. From here, V minus U is equal to AT. V minus U by A is equal to what? Time. So all we need to do is just substitute. Okay, V is equal to what? 200. We'll just keep the units aside because everything is anyway in the SI system. So time is going to come in terms of seconds. V is 200. U is what? 100. Divided by A is what? 10. Okay, so what is it? 200 minus 100 is anyway 100. So 100 by 10, what is it? It will be 10. Unit will be what? Seconds. So in how much time? The velocity is going to be doubled. It will be doubling in a time of how much? 10 seconds. So like this we will be able to go ahead and then use these equations of motion by following the sign convention. If the acceleration is in opposite direction, right, then we would be taking the acceleration value as what? Negative. In that case velocity will not increase, it will be actually what? Decreasing. So we will call that particular scenario as also by the name deceleration. When the acceleration is opposite direction to the velocity, right, we'll call it as what? Deceleration. So in any problem they say that the object is having a deceleration of 1 meter per second square, means we have to assume that 1 meter per second square is in the opposite direction to the initial velocity. Okay, accordingly we have to take the sign convention part. Now we look at one more question. The initial velocity of a body moving along a straight line is what? 7 meter per second. It has a uniform acceleration of 4 meter per second square. What is the acceleration value? 4 meter per second square. They are not saying it is deceleration. The displacement of the body in the 5th second of its motion. So what is given? U is given. Initial velocity is what? 7 meter per second. What is the acceleration? They are not saying it is deceleration. It is what? Acceleration. What is it? That's why we are taking it as what? Positive. 4 meter per second square. And we need to find displacement in the 5th second. Remember, here n is equal to what? 5. We have to use the Sn formula. Remember, what is the Sn formula? Here we have to find S5, displacement in the 5th second. What is the formula? U plus A by 2 into 2n minus 1. So U is what? 7. We will take everything in the SI system of unit, means S will be coming in what? The SI unit, which is the meter. So 7 plus A is what? 4 by 2 into 2n minus 1, which is what? 2 into 5 minus 1. So what is it? 2 1s are 2 2s are. So 2 into what is there? 2 5s are 10. 10 minus 1 is what? 9. So 7 plus 18, which is what? 25. So what is the answer? It is option A. So what is the displacement of the body in the 5th second of its motion? This is what we are calling as the Sn formula, the displacement of the body in the nth second. We'll look at another question. A car moving with a constant acceleration covers a distance between 2 points 180 meters apart in 6 seconds. Means what? This is one point, this is another point, point 1, point 2. What is the gap between them? 180 meters. It is covering this in how much time? 6 seconds. Its speed as it passes the second point, means this is the first point, as it is passing through the second point. Okay, what is the speed? Speed means what? The magnitude of the velocity. What is it? 45 meter per second. From this we have to find what is the acceleration. We have to find what the acceleration value. Look at what is given to us. We are given the t value, which is 6 seconds, and we also have the total displacement between point 1 and point 2. What is the displacement? It is 180 meters. What is the displacement? It is 180 meters. And we are given here the final velocity. What is it? 45 meter per second. From here we have to find what is the acceleration. From here what are we supposed to find? We have to find the acceleration. Do we have a formula? So relating S, V, T and acceleration. Remember, we have a formula for S, U, acceleration and time. What is it? S is equal to ut plus half at square. What is the formula we have? S is equal to what? Ut plus half at square. So here we are going to do something interesting. Look at it. We are going to modify the equation and with one more alternative form. So what is the equation we have? S is equal to ut plus half at square. This relates displacement, initial velocity, time and acceleration. But we are looking for the relation between displacement, final velocity, time and acceleration. See here, the u can be, because v is equal to what? U plus at. So we will take the at to the left side. V minus at is equal to u. We will substitute that. What is it? V minus at. Okay. So look at it. What is it? V into t is what? Vt. Minus at into t is minus at square. So what is it? Minus at square plus half at square. What is it? Minus half at square. Look at this, guys. This is another derived result. This is what? The relation between displacement, final velocity, acceleration and time. Why we are not counting it as an equation of motion is it is modification of the displacement equation. Displacement equation means generally we are representing in terms of what? Initial velocity, time and acceleration. But we can also have a displacement formula in terms of what? Final velocity, acceleration and time. What is it? S is equal to Vt minus half at square. S is equal to what? Vt minus half at square. Now, if we have got this equation, means we will be able to, we can make a note of this equation. This is also an important equation that we can use while solving problems. Now we will just go ahead and substitute the things in this equation as such, right? Because we know S, what is the S value? It is 180. So we'll just substitute. S is 180 is equal to V into T is what? 6. 45 into 6. Okay. Minus half into A into T square means what? 6 square is 36. So this is 18. So what we'll have? This 45 into 6, that is what? 270. 45 into 6 is what? 270. So we'll bring the 270 to the left side. 180 minus 270 is equal to what? Minus 18A. This is what? Minus 90 is equal to minus 18A. So 18 ones are 18 fives. So from here what we are getting? Acceleration is 5. In terms of unit, because everything is in the SI system, right? Unit is going to be what? Meter per second square. Look at this. What is the answer? It is option A. So here in this question, right, we will look at this result. The displacement equation in terms of what? The final velocity, acceleration and time. S is equal to Vt minus half at square. So look at another question. This is what we will generally call as the stopping distance problem. So here also we will derive a formula. Maybe we can remember it. If not, we can just apply that concept and then solve whenever we have the stopping distance. Stopping distance means nothing, so if you have a car or vehicle moving, we see some obstacle or something, or red light or anything, then we'll apply the brakes. So what we'll do, we'll apply the, so when you apply the brakes, what is going to happen? The car is going to get decelerated, means its velocity will be in the forward direction. The brakes will create an acceleration in the reverse, opposite direction. So this is what we'll say, the case of deceleration. The car is undergoing what? Deceleration. So the velocity will keep on decreasing and finally it will come to rest. The final velocity will be what? 0. And it is getting stopped. When the final velocity is 0 means what? It is getting stopped. So the distance covered means whatever is the gap between the time where you apply the brakes and the time where it is getting stopped. This is what you call as the stopping distance. Stopping distance or stopping displacement. Okay. We'll see in case of straight line motion, right? When the distance and displacement magnitudes will be different, when the object is moving in one direction, the distance value and displacement magnitude both will be what? Same. The difference will come when it is going in one direction for some time and reverses. That is when the distance and the displacement will be becoming different. We will talk about examples on that also. Here it is going in one direction, it is not reversing, it is getting stopped, that's it. So the displacement will get, remember one thing very important in the equations of motion, right? S is always what? Displacement. S is always what? Displacement. Okay, or the displacement value. Now during the 1D motion, if there is no change in the direction, change in direction will come when the initial velocity and acceleration are in the opposite direction. The velocity will decrease, it will become 0, and after that, if it is allowed to move, means it will start moving in the reverse direction. Okay, here it is not the case, it is getting stopped there, that's it. We apply the brakes, so long the vehicle is going to stop, after that we will release the brakes. No. So the concept of distance covered and displacement will be same when we have the object moving in a straight line without changing the direction. We will see some examples, particularly when the difference will come when the object is changing its direction, and that will happen when the object is having acceleration in opposite direction to the initial velocity. Okay, so we will call those type of problems as the distance and displacement comparison problems. We look at those type of questions also, so that we will be clear as to when the distance covered and displacement will be different. So in these kind of examples, right, when it is having acceleration, where the A and U will be in the same direction, in those cases what is going to happen? The object is going to move in the same direction with increasing speed. So the displacement value we calculate from that formula, right, S is equal to ut plus half at square, will be nothing but the distance also. In this case also same, because it is not changing the direction of motion, it is going and then stopping. So the displacement value we get will be equal to what? Distance covered. That is the reason why we are using the word stopping distance. Okay, now we will have to solve this case of the stopping distance. So first we will solve this question, then we look at what is the general formula for that. A car is moving with an initial velocity of 8 meters per second, means always as per our convention, right, initial velocity, whatever is the direction it is, we will take it as what? Positive, and has a deceleration, it is having a deceleration of what? 2 meters per second square, means we have to take acceleration as what? Negative, means it will be, so if the car is moving forward, means the brakes applied will create a deceleration in the backward. Okay, what is the distance covered by the car before it stops? So here we are generally saying that brakes are applied, but the deceleration in the car can be created by different reasons also. Maybe there is a lot of sand. If you are trying to drive the car in sand, means you will get decelerated like that. But generally what is the reason for the deceleration of the car? It is the applying of the brakes. Okay, so what is it that we are trying to find? What is the distance covered by the car before it stops? What is stopping condition means? Final velocity is 0. In that you have to find what is the displacement, because since it is not changing the direction of motion, displacement value we will get is also going to be the distance covered. So look at it, U, A, B and S. What is the equation we have? V square is equal to what? U square plus 2AS. From here, V square minus U square is equal to 2AS. From here, V square minus U square by 2A is equal to S. This is the formula. Okay, so here V square means what? 0 square minus U square is what? 8 square, divided by 2 into A. 2 into A is what? Minus 2. So numerator is what? Minus 64, divided by denominator is what? Minus 4. Minus minus is cancelled. 4 ones are 4 16ths. So what is the displacement of the car, or the distance covered by the car before it is coming to rest? It is what? 16 meters. So this is what will be the stopping distance. Okay, this is what will be the stopping distance. Now we'll said we'll look at the general formula, right? General formula for the stopping distance. So we are going to just get it from this particular step. What is the S value we are having? S is what? V square minus U square by 2A. So in this, right, V is always what? 0, because we are talking about the stopping, means 0 square minus U square by 2A is equal to what? Yes, 0 square means 0 only. So what is it? Minus U square by 2A, that is our S. So this is the formula. So here now why this minus is coming? Because acceleration we are going to substitute will be negative here, we can keep in mind. So what is it? The acceleration we are going to substitute will be what? Negative in this particular case. Okay, Otherwise, some people also remember it like this. Since we are only talking about the distance, right? We'll take a modulus. So when you take a modulus means what? Modulus of minus u square by 2a means what it will be? Mod of u square by 2a. Because when you take a modulus means minus of modulus will be what? Minus will not come, right? So either you remember it like this, minus u square by 2a, stopping distance, or you can remember the modulus value, modulus of u square by 2a, like that you can remember. Okay. So this is about the stopping distance problem. This is a very important problem. I mean, these kind of questions have come in some of the previous year AIEEE or the erstwhile JEE mains version. So this is about the equations of motion in one dimension, and what is the sign convention concept that we'll use in the case of the horizontal straight line motion. But what about the sign convention we'll have to follow in the vertical straight line motion? See, remember, the basic idea of the sign convention we have to keep in mind. What is the basic idea of the sign convention? If one direction quantities we take positive, opposite direction we have to take negative. That is the basic idea. Now in the vertical straight line motion, what we see is sometimes the object may be going up, sometimes the object may be coming down. The initial velocity sometimes may be, because if you say for example we'll throw an object up, then what is the initial velocity? It is what? Upwards. We will throw an object down, then what is the initial velocity? Downwards. So sometimes the initial velocity may be upwards, sometimes it may be downwards. Just to make things very much clear, what we'll do is, generally in vertical straight line motion we'll follow a fixed convention. That is, anything upwards we take positive. So any quantities which are in the upward direction we'll take it as what? Positive. Anything in the downward direction we will take it as what? Negative. Anything in the upward direction we'll take it as positive, anything in the downward direction we'll take it as what? Negative. That is the general sign convention we'll follow in the vertical straight line motion. Now some people might also argue, why not we follow the sign convention based upon the problem? If in a particular problem our initial velocity is upwards, we will take upwards quantities positive, downwards negative. If in another problem the initial velocity is downwards, we will take the quantities downwards positive and upwards negative. You can as well do that, okay, because there is nothing that is going to stop you, because that is also correct. Basic idea of sign convention is what? One direction quantities you take positive means the quantities which are in the opposite direction we should take negative. That's it. Okay, but this is a little bit more convenient to follow, because we will be at least clear. Everything up is positive, everything down is negative. Okay, so you can look at this convention that is there for the vertical straight line motion. Anyway, we'll discuss about the vertical straight line motion in a separate video in detail, because we have multiple cases to discuss in the case of the vertical straight line motion and some standard results in the case of the vertical straight line motion. We'll discuss about it in detail in a separate video. Okay, so this is about the equations of motion in 1D and the idea of sign convention we use while following the scalar form of equations. We'll get the scalar type of equations in the 1D motion with uniform acceleration, but while using the equations we have to follow the sign convention. We'll see in the next video.